Hello good day viewers. In this tutorial we are going to learn how to solve a quadratic binomial applying difference of two squares. This is the general form of any quadratic equation. So if all the three terms are available, then we say that quadratic equation is a quadratic trinomial. But once you have the leading term and any one of these two, we regard it as binomial, right? And when you have only the leading term, because the minimum you can have is the leading term, x squared. Once you have only ax squared as a quadratic equation, we call that quadratic equation a monomial. So the kind of quadratic binomial I want to show you how to solve is when you have the leading term and the constant. Therefore, if we have ax squared plus c equal to 0, we want to find out how to solve this type of equation applying difference of two squares. And we are going to solve 4 problems, 2 with real solutions and 2 with imaginary solution or complex solutions. Okay, let's start with the first one. Remember that difference of two squares, if you have a squared minus b squared, this can always be factorized as a minus b multiplied by a plus b. They are just conjugate of each other. So let me give you one example. The first one, suppose we have only x squared minus 4 equal to 0. I told you we want to solve a binomial in which has the leading term and the constant term. You know 4 can be expressed as 2 squared. Therefore, we can write this one as x squared minus 2 squared equal to 0, which are now difference of two squares. We can factorize them as x minus 2, right, multiplied by x plus 2 equal to 0, so that we can set each factor from here to be equal to 0. Since we have two factors multiplying each other and the result is 0, it implies that either of the factors will be equal to 0, right? So we're going to set each of these factors to be equal to 0. Setting this one to be equal to 0, x minus 2 equal to 0, it implies that what? X must be equal to 2 for this statement to be true, because 2 minus 2 is 0. And if you set this one to be equal to 0, that is x plus 2 equal to 0, it implies that what? X must be equal to negative 2. So you see, this is exactly how to solve a quadratic binomial applying difference of two squares. But the question is, what if this number is not a perfect square number? This is why I say in each case we're going to have 2 examples. So let's take the second one. So the second example, suppose we have x squared minus 3 equal to 0. We cannot express 3 as any number to the power of 2, but not always, because square root of 3 squares is the same thing as 3. So instead of this, we can replace it with this one. So we have x squared minus the square root of 3 also squared. This is the same thing as 3. So from here, we can apply difference of two squares to factorize this as x minus the square root of 3 multiplied by x minus plus square root of 3 equal to 0. Setting each factor to be equal to 0, it implies that x could either be square root of 3 or x equal to negative square root of 3. And these are just the solution to this problem. So the second one, suppose we have x squared plus 4 equal to 0. This time around, you can see we have positive sign. So we have x squared plus 2 squared equal to 0. These are sum of two squares, not difference of two squares. But remember, in our complex number, we have learned that I squared is equal to negative 1. Therefore, we can attach negative sign here. But since it was not there before, we can write it like this. X squared minus 2 squares, right? And because of this negative sign, which is the same thing as negative 1 times 2 squared, we can replace it with this one. So it becomes x squared minus 2 squared I squared equal to 0. Can you see that? This I squared is -1 times this negative will turn it back to positive number. And you know, from one of the laws of indices, we can assign this one the same power because they have the same power, 2. So this is x squared minus 2i all squared. This is equal to 0. Now we have difference of two squares. This is x minus 2i multiplied by x plus 2i equal to 0. By setting each factor to be equal to 0, it implies that either x equal to positive 2i or x equal to negative 2i. This is exactly how to transform this into difference of two squares. Let me take the last one where we have non-perfect square number here. So example, suppose we have 2x squared plus, let me use 5 equal to 0. First of all, let us divide both sides by each term by 2. So this becomes x squared plus 5 divided by 2 equal to 0 divided by 2, which is still 0. And from here, we can write this one as x squared plus square root of 5 divided by 2 all squared. So from here, we can introduce that negative sign. So we have x squared minus square root of 5 divided by 2 all squared, but remember to attach I squared. This is equal to 0. This has a squared, this has a squared. From one of the laws of indices, you can assign them a single exponent. This is x squared minus the square root of 5 divided by 2i, all of this squared equal to 0. Now we can factorize it applying difference of two squares. This is x minus root of 5 divided by 2i. They are multiplied by x plus root of 5 divided by 2i. This is equal to 0. By setting each factor to be equal to 0, it implies that x could either be positive root of 5 divided by 2i, or the other one, x equal to negative root of 5 divided by 2i. As simple as this. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos.